finish up 1.3. We talked yesterday about analyzing graphs, finding intervals of increase, decrease, constant, domain and range, that sort of a thing. We are now going to talk about piecewise functions, all right? Piecewise, hopefully you guys have seen this before, but it's not that difficult of a concept. It can be a little confusing at the onset of it, but it's really not bad. If you look at this piecewise function here, okay, this is what it looks like. F of x is a fancy way of saying what? Y, okay, we know that. So what you are given here are two lines, y equals 2x plus 3 and y equals negative x plus 4. How do I know they're linear? Because x is to the first power. And then they're graphed over here, but the entire line is not graphed, only pieces of it. So what we're going to do is we're going to graph each line or parabola, whatever it is, and then we're going to decide, given the parameters of your piecewise, which are right here, we're going to decide what part of the line we need to keep and what part of the line or graph that we need to get rid of. So in the first example here, it says y equals 2x plus 3. That's the one on the left-hand side. And then I have y equals negative x plus 4 on the right-hand side. Okay, we need to know slope is the number in front of our x. The intercept is behind once we're in y equals mx plus b. This right here tells us where our boundary line is. Okay, it's telling you what values on the x-axis satisfy this part of the graph. So let's go through and actually do one, all right? Let's just do one. We're not going to do 57. We're going to do 55 and 59. And then we're going to move on to the quiz review because that's what I really want you guys to focus on. A lot of you are having issues putting things into WebAssign, not understanding exactly what the question's asking. I get that, all right? These first few lessons are hard in WebAssign. They're hard to get into. Just do the best you can. I'm going to be lenient with the grading. What I need you guys to focus on is the quiz review and that you notice the material that's on it. All right, so if I look here, I have two lines. Do you guys agree with me that I have two lines here? F of x is a fancy way of saying y. So I have y equals 2x plus 3. And here I have y equals, I'm going to rewrite it as negative x plus 3. It's already in slope-intercept form. For my blue line, my intercept where it crosses the y-axis is at positive 3. And my slope is 2 over 1. So we're going to graph that line. Right now I'm going to say, okay, positive 3 is my intercept. And I'm going to graph 2 over 1. So up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. Does everybody agree with me? It's a positive line, so it's sloping upwards. I'm going to draw, it's easier for you guys on Notability too. I'm going to draw a dotted line because it's easy. We're going to have to erase here in a second. And I have arrows at the end of my line. Okay? That was middle school graphing lines. Now, what makes this a piecewise function is you have a boundary. You have a parameter that you have to take into consideration. They want you to look where the boundary is 0. So I'm going to take a line, draw a vertical line right here through 0. And I'm going to read that inequality. It says, I want all of the values on that blue line where x is less than 0. So if I'm looking at my yellow line, where are the values less than 0 on the x-axis? To the left of it or to the right? To the left. So I want to keep all of these values over here on the left-hand side. I want to keep this part of my line. And what do I do with the stuff on the other side? We erase it. So that's the piece of the line that I wanted. Before I move on to the next part, I need to look at the notation. That says x is less than 0. So what kind of a dot should I have right here on my boundary line of 0? I should have an open dot. All we're going to be doing, guys, is either drawing lines and erasing some pieces or drawing parabolas and erasing some pieces. That's it. I'm now going to move on to the second line. It says y equals negative x plus 3. Well, think about this. Negative x. It's going to be a downward sloping line, right? My intercept is at 3, positive 3. And my slope is negative 1. So I'm going to go right here to positive 3. Put a dot. Down 1 over 1. Down 1 over 1. So on and so forth. And then I'm going to just connect my dots and draw my line. Again, I'm doing a dotted line because I know for you guys it's easier on Notability. Yes?
On missed how you like started the line. Like there, how you
I put my point at 3, my intercept at 3, because the y-intercept is 3, and then my slope is -1. So from the intercept, I went down 1 over 1, down 1 over 1, down 1 over 1. Does that make sense?
Yeah.
Okay. Now again, where is the boundary line we're looking at for this one? Where am I going to draw a vertical line? At 0 again. Sometimes it's at the same spot, sometimes it's not. So I have my boundary line right here at 0. And I read the inequality. It says for this red line over here, I want all of the values on the red line that encompass where x is greater than or equal to 0. So looking at that green vertical line, where are the x values greater than or equal to 0? To the left of it or to the right? To the right. So that means I want to keep all of this. And what do I do with the other stuff? You erase it. Perfect. Good. And then what kind of a dot should I have here on my red piece? A closed dot. Why? It is equal to. So now somebody might ask, well, wait a second. How do you know if it's supposed to be open or closed? Guys, follow the rules. In this case, you have an open dot, correct, on the blue line, but you have a closed dot on the red line. So what's going to show up on your graph is your closed dot. But understand that 0 is included in the red one, but not included in the blue one. But your piecewise function is just going to be a couple pieces of different graphs. Does that make sense? If you guys saw this last year, it's a good review. If you didn't, then we're going to learn it real quick. All right, let's go to 59. I'm going to do 59 here. You guys aren't going to have a square root 1 on your quiz. We'll work on that later when we get to the end of chapter 2. So we'll just skip it for right now. How many lines am I going to draw for 59? 3. How do I know they're all lines?
No square.
Nothing's squared. Good. Everything's to the first power. So I have 3 lines. We'll do 3 different colors. I have y equals x plus 3. I have y equals 3. And y equals 2x minus 1. Okay, so y equals x plus 3. My slope is 1 over 1. And my y-intercept is at positive 3, correct? Okay, so I'm going to go right here. I'm going to put a point at 3. My slope is 1 over 1, and it's positive, so it's going to be going upwards like that. So up 1 over 1, up 1 over 1, down 1, down 1. Okay, there's my... What is the vertical boundary that I'm going to draw? Where am I drawing my boundary for my first one, x plus 3? At 0. Okay, so we're going to go right here at 0. Now I'm going to look to the left and to the right. I'm going to read the inequality. It says all the values where x is less than or equal to 0. Where are all the values less than or equal to 0? To the left of the line or to the right? To the left. So everything over here is what you want. And what do we do to everything on the other side? You erase it. Good. What kind of a dot do you have at the boundary line right there? Why is it closed? Because it's included. Good. Alex, did you have a question, honey?
Yeah, I didn't really look at the line from the middle. What is that?
That is where, so that is what kind of defines that this is a piecewise. They're telling you that that's the piece of the graph that you want to keep. That's going to be, you're going to draw that vertical line, and then you look to see what the inequality says, and that's where you keep the part of the line. Look at the next one. Let's go blue, all right? This is always tough for us to graph. Where, guys, and what does it look like is the line y equals 3? It's a horizontal line through what? Through 3. So look, just like this. Okay? Now, what is the boundary? What am I looking between, or where am I looking? Between what two numbers? 0 and 2. So I'm going to go where x is 0, draw a line. I'm going to go where x is 2 and draw a line. The inequality says you want the piece of this function, you want between 0 and 2. So where am I keeping and where am I getting rid of? I'm going to keep this stuff here in the middle. And then what do I do with everything else? I'm going to erase it. Good. So we're going to erase. And what do I have at the end of my little blue piece? Look at your inequality. You have an open dot where? At 0, but a closed dot where? At 2. All right, since there's already a closed dot there at 0, you can keep it like it is because your closed dot will supersede the open one. And now we're going to go to pink. I have the line 2x minus 1. So my slope here is 2 over 1. And my y-intercept is at negative 1. It's a positive line, so I'm going upwards like that. So I'm going to go to negative 1, put a dot, and then my slope is 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And I'm going to go ahead and draw. And I'm going to look at my last boundary, my last parameter. I want all the x values that are what? Greater than 2. So I'm going to go right here to 2, draw a vertical line. To the left or to the right, where are all of the x values greater than 2? To the right. So I'm going to keep all this stuff. And do what with the other stuff? And erase it. Good. Now you already have a closed dot there. So 2 is not included on the pink line, but it is included on the blue line. But there is your piecewise function. You have a piece of this one, a piece of that one, and a piece of the other one. Biggest thing to do, guys, is to take your time. You cannot do all 3 lines at all the same time and try. Just take your time. Do one line, see what you want to keep, see what you want to erase. Do the second piece, see what you want to keep, what you want to erase. Yes, ma'am?
How is like the y-intercept like not? I think I was like on the third one. Why wasn't the y-intercept not negative 1?
It was.
It was.
Yeah. Yeah.
Why wasn't it like we just deleted everything?
We deleted everything that was less than where x is 2.
Did you say for the quiz the problem with the homework?
The quiz review. Yeah, which is what we're going to do in just a minute.
There's something like this. There's something like this.
Yeah, I'll show you exactly what's going to be on it. All right, so let's move along. This is in modules. I posted this in modules. I think it's right above your quiz assignment. But this is in modules, and the worked out key is in modules. Ms. Carver's handwriting. Her handwriting's better than mine. You're going to have questions very similar to this. I want you guys to, right out the gate, right? It's very early in the school year. Generally, when I give reviews, they are similar to what the tests and quizzes are, but they're not going to be exact. It's not going to be like here. There's 10 questions on the tests and there's 10 questions on the review. It's not like that. But this first review is a very good structured thing to try and set you guys up for some success at the beginning. All right, as you get going, you need to be able to practice on your own. You need to be able to go through your notes. You need to be able to look back at examples and stuff like that. But you do need to just kind of focus for this first quiz on this. I'm trying to be straightforward in this first one. So if you guys look, the first question, everybody will have a question that says, hey, here's 2 points. Find the distance, the midpoint, and the slope. All right, you're going to have to keep your answers in a simplified radical form. You will not be given the formulas, so let's write them down. Just so you guys remember, your slope, y2 minus y1 over x2 minus x1. All right, y's are on top, x's are on the bottom. If you flip it, guys, it's wrong. Some stuff I can give partial credit for, some I can't, so just make sure you're on top of things. Your distance formula, all right, you subtract the x's, square them, subtract the y's, square them, and then add that together underneath the square root.
Does it matter which order?
Nope, it does not matter which order, because think about it, you're squaring, right? So if you take, like in letter B, if you take 12 and 4, 12 minus 4 is what? 8, 8 squared is 64. 4 minus 12 is what? Negative 8, what's negative 8 squared? 64. So since you are squaring underneath the square root, it doesn't matter which you make x1 and x2. All right, last formula that will not be given to you guys is midpoint. Ms. Chung did this today with her geometry class, so I know everyone has seen it, probably 17 times. But midpoint, how do you find the midpoint? You add the x's and do what? Divide by 2. You add the y's and divide by 2. Again, does it matter if you say 4 plus 8 or 8 plus 4? No. But understand, guys, this is a point. It should be a number, comma, a number, and in parentheses. If you can simplify the fraction, simplify the fraction. If it's not a fraction, don't worry about it. If you came out with a distance of the square root of 40 and left it, is that simplified? No, all right? We would break that down into 4 times 10, so then this would be 2 root 10. Just make sure you guys are simplifying, following directions. One thing, guys, I will not answer questions during a test or a quiz. That is not the time for you guys to have questions. Am I on the right track? Did you mean this? I'll let you know if you're on the right track when I grade it, okay? So just make sure you guys are independent thinkers. There's a ton of different versions. Don't think I would ever give the same version. All right, look at the next, something like the next one. You guys will be given a question like this. Very basic. It's going to say, find the slope, the y-intercept, and graph it. Guys, can you just look at this and tell me what the y-intercept is? No. Can you look at this and tell me what the slope is? No. What form do we need to get this in first? Slope-intercept. I need this to say y equals mx plus b. So I'm going to add, and I'm going to subtract, right? I'm going to add x and subtract 9 from both sides. So we have 3y equals x minus 9. What's my next step? We're going to divide by 3. So if you were to answer this question, because the question is going to say, what is the slope and what is the y-intercept? What is the slope for this line? 1/3. Where's the 1? It's invisible. It's in front of the x. But you guys would answer, okay, slope. You would say m equals 1/3. It's not 1/3 x. Your y-intercept, you would tell me y-intercept is at 0, -3. You could say y equals -3. Don't just write a random -3. Be very diligent with your answers. And then you graph it. So you put a point at -3, right? Up 1/3, up 1/3, something like that. Okay, moving along. All right, if you're given sets of points, if you are given an equation, if you're given any equations, and they ask you, are these lines, or determine if they are parallel, perpendicular, or neither? All right, first of all, you got to show work. If you just guess right, but you don't have any supporting work, you're not going to get credit for it. But how would you know? What's the way to tell if lines are parallel, perpendicular, or neither? Yes, sir.
So if it's parallel, they have the same slope.
Perfect. Parallel. Good. Hang on. Same slope. Keep going, Chris.
And then if it's perpendicular, it would be the opposite.
Opposite, reciprocal. Remember, it's both. Opposite signs and flipped. If it does not fall into one of those two categories, then your answer is neither. So guys, if you have like 3/4 and 4/3, are those parallel? No, they're not the same. Are they opposite reciprocals? Are they perpendicular? No. They're close. They're kinda, right? Because they're reciprocals, but they're not opposite signs. Has to be both things, or it has to be the exact same. 3 and -3. It's close to being the same, but it's not exactly the same. So both of these would be neither, okay? Just make sure you're aware of that. All right, scooting along. I spent a good bit of time on our 1112 notes on a question very similar to this. Given an equation, can you write the equation of the line that is parallel or perpendicular through a particular point? There is a long example on your 1112 notes. Go back and look at the video. But understand, guys, if you're given an equation like this, you have to first go into y equals mx plus b to find the slope. Then I personally would take the point that's given and the slope that I discovered or determined, and I would put it into point slope form, and then algebraically manipulate to y equals mx plus b. If you just want to go right into y equals mx plus b by finding the y-intercept, that's fine as well. I just think that one's a little easier to do. But again, look back on your notes. All right, we're going to talk about these 4 graphs, and then I'm going to go over a piecewise, and then we'll be done. Yeah, we got time. 25 minutes, yeah. All right. Your quiz has 6 questions. You guys are like, what? 6 questions? One of them is, hey, here's a graph. Tell me the domain, the range, interval of increase, decrease, constant. So there's parts to it. So don't freak out that there's only 6 questions. It's longer than that. C and D are very straightforward graphs. We should be able to answer these without really thinking much. All right, we should be at that point now. So if I look at C, and I ask you guys to tell me the domain and the range. What's the domain and the range for C? Negative infinity to positive infinity for both the domain and the range. Look at the direction of the arrows, opposite directions. So it means it's forever and ever and ever getting wider. It's forever and ever getting longer, taller and shorter, however you want to say it. When we talk about intervals of increase, decrease, and constant, first of all, what are the notations that we always use for increase, decrease, constant? Always use parentheses. Good. This one's not exact, so I mean the answers are on the quiz review answers in modules, so you can look at it. But I just want to go over some things to remind you. What axis do we look at? X-axis only. So what did I tell you guys yesterday? What should we do with the y? Cross it off. Don't even look at it. Before you answer this, what can you tell me there's absolutely none of? A constant, right? So you can already write none. But you're looking for turning points. We start at the left-hand side of the graph and we move to the right. Same way you read a book. So it goes up and then it goes down and then it goes back up. So you'd have 2 intervals of increase, 1 interval of decrease. So let's do D together. D is a very, very, very straightforward question. What is the domain and what is the range for D? You guys tell me right now what the domain is, left to right. What's the domain? 0 to 7. Perfect. What's the notation on the ends? Bracket on 0 and a parenthesis on 7. How come there's a bracket on 0 but a parenthesis on 7? Good. Closed circle is included. Open circle is not included. All right, what's the range? We read range from low to high. What's the lowest that this graph goes? -1. And what's the highest? +3. What notation goes on the end of this one? Bracket on both. Somebody asks, well, I don't see a dot. Guys, think about it. If you draw a line, how do you make a line? It's just a whole bunch of what put together? It's a whole bunch of dots. So where there is a line, a dot does exist. All right, so now I'm going to write my increase, decrease, and constant. We read from left to right, and we use just parentheses. What should I cross off so I don't get myself confused? Cross off the y, guys. Don't even look at those numbers. All you're looking at is the x-axis. So when I put my pencil right here at the beginning of this graph and I follow it, what am I doing? Decreasing from where on the x-axis? Good. To where on the x-axis am I decreasing? Perfect. Good job, guys. 0 to 2. So then I say, ooh, there's a turning point. Now, what did we do? We're starting to go up. Where are we increasing? From where on the x-axis to where on the x-axis? 2 to 6. Perfect. And then I look and I say, okay, there's another turning point. What does my graph begin to do there? Decreases from 6 to 7. Is there an interval of constant? Should I just leave it blank? No, right? None. There isn't one. Doesn't have. No. Something to let me know that you understand there is no interval of constant. All right, does that make sense? Yep.
So, like, for C on the other side, if it's something like that where it doesn't land specifically.
Right, I gotcha. Like if you're here and you're like, oh, I'm not exactly sure. Your graphs tomorrow will be specific.
Okay,
Mhm.
but like for there, would that be like 2.5?
Ish. -2-ish, something like that. All right, I want to focus on these two graphs because these are a little more challenging. All right, you might get something that's a little more challenging tomorrow, not super straightforward and spoon-fed. So I want you guys to see this. First of all, talk to me about this graph. What do you guys notice? Okay, one has an arrow, one has a dot. It's confusing. Okay. What else do you notice? It's split. Good. It's not one continuous thing. So these are a little more difficult to identify your domain and range. Interval of increase, decrease, constant, you guys are fine. Increase means going up, decrease means it's going down. Okay, fine. But the domain and range can be tricky when you have a graph that is not continuous. So let's look at this for a second. This is the best way I can say to describe this. First of all, I have an arrow on the left-hand side, correct? There's an arrow over here. That means we're coming from left to right from negative infinity. So I know that my domain is going to start out here with negative infinity because there's an arrow that's saying, hey, it's going to keep on going. So we're coming from over here. So as I look from the left-hand side to the right-hand side, I see that, look, all of the x values are being used on this blue graph, correct? Up until what point? 1. What happens at 1, guys? It's not, there's an open dot, which means that is not included. Both of the dots at 1 are open. So your domain for this first part of the graph, we're not writing two different domains. This is one graph. We're going to encompass the whole thing. Is negative infinity to 1. What happens at 1? There's an open circle at both places, right? What happens just after 1? Your graph picks up again, right? So your graph picks up again at 1. And it goes to 4. Does it include 4? Yes. Does it include 1? No. What would your domain be if one of these dots, like on WebAssign, was closed? Negative infinity 4. Perfect. That one little change made a huge difference because the circle was open or closed. If they won't both be closed because then it wouldn't be a function. Good question. Because it would include 1 at one point. Like, it was just like the one on WebAssign. Like, if that was closed up, then 1 would be included at some point. So it would just be everything from left to right. Just because it's included on one piece, but not the other one. But it's one full graph.
So that would not connect.
Correct. All right, now let's talk about our range. How do you guys figure out range? Bottom to the top, okay? Bottom to the top. This is easier to do in Notability. Okay, so again, so we can visually see this. Where does the range start? At -1, I agree. So my range starts at -1. It includes -1. It is included, so -1. And where do values of this graph, either piece of it, where do they exist? Well, keep going. Here, here. Now, there's a break on the right-hand side, correct? But are these values on the y-axis being used on the left-hand side? Yes, so you're still good. You're still good, you're still good, you're still good. Uh-oh, then it stops here, right? It stops on the right-hand side, but what about the left-hand side? It's still going. So what is your range for this graph? -1 to infinity. It does not, you're not looking at each piece separately. You're talking about the whole graph as one unit. So if there is a break in the action, you have to make sure that you account for it. All right, so let's do this. All right, let's change this to this. Do you guys see here a specific break where there is neither piece of the graph exists in that red rectangle, correct? So your domain here would have a specific break from negative infinity to 0, and then it picks back up again at 1. So it would be negative infinity to 0, union, 1 to 4. You're looking for specific breaks, and it has to be where everything on the graph is non-existent, not where just one piece. Well, it's not on this piece, but it's on the other piece. If it's on one piece, then you have to account for it. So let's look at this one. Having said that about that graph, let's look at this one. And I'm going to do this one a couple different ways. I'm going to change it a little bit so you guys can see. I want to talk about the domain and the range. Again, arrow on the left-hand side. So we're starting, it's coming from way out over here, right? Everything on the x-axis, everything, but it stops.
Why is there not a union?
Say it again.
For 5, why is there not a union?
For which one?
For range.
Over here? Oh, I changed I changed this question from this.
No, I know. I'm saying for the range from the beginning part. Why is there not a union?
Because where there's a gap here, yes, I agree, there is a gap, but over here, those y values are being used on that part of the graph. So it's not that there's like absolutely nothing being used in that section. It's just not on that one piece, it's on the other one. But what do you guys notice here? It stops right there at 2, correct? Up here? But what does it do down here at 2? It counts. It picks up. Do you see how the dots are on top of each other? It's just like with WebAssign. So it's not included on the parabola piece, but it is included on the constant piece. So what is your domain for this function? Negative infinity to positive infinity. Negative infinity to positive infinity. Now I'm going to change the graph in a second to give you guys a little different look of what it could possibly look like. Hang on. Again, this is easy on Notability. Now, everybody just kind of pay attention. Hold on to your hats here for a second. How do you read range? From bottom to top, okay? So where does this graph begin to exist? At a -1, right? Do you guys agree that there's a value right there at -1? Then what happens? Then there's a gap. Do you guys see right here? There is absolutely no piece of your green graph in that space. Do you see that? So the way that you would write your range is you would say, okay, -1 it's definitely there at -1, correct? It's a constant piece. Does it include -1? Yes. But then where does it pick back up since there is a gap? Where does it begin again? 0, and it goes to what? Infinity. Do you visibly see that gap? Everybody see it? Okay. Now, if I was talking about increase, decrease, constant, does this graph have all of those things? Yes, it's decreasing from negative infinity to 0. It's increasing from 0 to 2. And then it's constant from 2 to infinity. But if the graph looked like this, say it looked like this. Do you see a specific gap? A break in the action? Do you guys see it? Right here. You see where your graph does not exist in either piece of that. So your domain for this function here, your domain would be negative infinity to what? To 0. Does it include it? Okay. And then it picks back up again from where? To infinity. Do you still have a gap, ladies and gents, in the range, the way that this is drawn? Yes, there's still a piece right there that does not exist. So in this case, your range would be, it exists at -1. And then what would it be? 0 to infinity. Always have parentheses, yep.
It's just -1 because it's a straight line.
Mm-hmm. Because that's the only value, right? It's all of the x's are used. That's why the domain is bigger. But there's nothing above -1, nothing below -1. It's just right there at that y value. That can be kind of hard to wrap your head around. So I just want you guys to see that. All right, let's look at the last piece. Haha, it's a piecewise. All right, we'll do B. Again, all of these worked out. It's posted in modules, everything I'm doing. But I want you guys to notice, let's look at B. All right, are all three of these lines? No. What's the second one? A parabola, okay? If you don't remember that, make note of it. Anything square is a parabola. It's going to make a U shape. A positive parabola is happy, it's going up. Negative parabola is sad, it's going down, okay? So let's talk about what this is going to look like. I have y equals 0. I have y equals -x squared plus 4. And y equals -x plus 3. All right, where is y equals 0, folks? It's just the x-axis. Good, okay, so it's just this line right here on the x-axis. So now we look at our boundary lines, all right? My boundary lines, where am I drawing two vertical lines? At where and where? -5 and -2. So I'm right here at -5, 2, 3, 4, and right here at -5 and -2. If I read that inequality, it's saying x is in between. I want the values in between -5 and 2. So where am I keeping and where am I erasing? I'm keeping what? The stuff in the middle, and I'm erasing everything else. Good. Okay. Fair enough. And what kind of dots do I have on the left-hand side or the right-hand side? Left-hand side is closed. Good. Right-hand side is open. How do you know it's open? Because it doesn't include. Good. All right, let's look at the next piece. -x squared plus 4, which we just talked about, guys, the parabola. It's going to cross the y-axis at 4. It's pointing downwards. But you don't know exactly where the points are going to be, so we're not going to just kind of guess. We're actually going to make an XY chart. And we're going to figure it out. So I'm looking between -2 and 1, so I'll say -3, -2, -1, 0, and 1. Now, we can't forget our algebra rules, right? This says -3 squared plus 4. Well, what is -3 squared? 9. So there's this negative out in front. So it's -9 plus 4 is -5. Because I have to draw that picture. Like, you can't just go to 4 and be like, oh, it goes like this. Right? We have to be specific because we have specific numbers and boundaries that we have to abide by. So now I have -2. So I have -2 squared plus 4. Well, what's -2 squared? 4. And then there's that negative out in front. So it's actually -4 plus 4, which is 0. Now I have -1 squared plus 4. -1 squared is 1. That negative's still there out in front. So -1 plus 4 is 3. If I plug in 0, what's 0 squared? 0. So -0 plus 4 just gives me 4. And then when I plug in 1, it's going to be the same as -1, but 1 squared is 1, and the negative's out in front, so this is going to give me 3. So if I plot these points, -3, 5, 1, -5, 1, 2, 3, 1, 2, 3, 4. Then it's -2, 0, 1, 3. Then here, then here. All right, so now, Alec, do you see now you have your shape of your parabola? Yeah. Where is the boundary line that I'm going to draw, or lines? Or am I looking in between where? negative 2 and 1. So I'm going to draw a vertical line at negative 2 and a vertical line at 1. It says x is between there. I want the values between negative 2 and 1. So I'm going to keep this stuff here and do what with everything else? Erase it. Okay, is my parabola perfect? No. Can you tell, though, that that is a parabola and not a straight line? Yes. You need to make sure of that, guys. I don't want to have to guess. Did you do this as a parabola, as a line? You need to, if you don't know exactly what it's going to look like you can, just plot your y-intercept and your slope and draw your line. If it's going to be a parabola, you need to actually plug in some values and get the shape correct. Now, the last piece, we'll do in pink, and then we're done. My last piece is a negative downward sloping line. My intercept's at 3, so 1, 2, 3. And we're going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, right? So something like this. And then my boundary line. I don't like the way that's written. It says 2 is less than x. Anybody know how to rewrite that so the x is on the left-hand side? X is greater than 2. Just read it backwards. If you want to rewrite it, it says x is greater than 2. That's fine. But I want all the x values that are greater than 2. So here is 2. Where are the x values greater than 2? To the right of that red line or to the left? To the right. So I want to keep everything to the right, and I want to do what to everything on the left? Erase. Good. And lastly, what kind of a dot should I have there? Why is it open? Because it's not included. If you need to go like this to say, hey, that's open. I don't know if you can't tell or not. That's fine. You can do that. Whatever you guys need to do to alert me, that's fine. Okay, we good? Yes? No? Maybe so? Okay.